On this episode of the podcast, I have with me Arjun Bansal. He is the CEO of Log10. We're going to be talking about LLM accuracy. In that is going to be a lot of stuff we're going to try to unpack, hallucinations, improving accuracy. Arjun has a phenomenal background that is applied in a very maybe unique way. So we're going to ask him how he actually applies that. I'm not going to spill the beans. I'm going to have him tell you all what his background's like, because I think it's pretty cool. And we're going to be talking about the notion of the black box when it comes to LLMs and understanding the black box. Arjun, thanks for coming on. Thanks for being here to share with us.
Thanks for having me, Amir.
So before we start, two things. One, what does Log10 do?
Yeah, Log10 is a platform that's been purpose-built for measuring and improving LLM accuracy. Like you mentioned, LLMs suffer from hallucinations, inaccuracies, biases. At the same time, they've unlocked this promise of very intelligent systems, building up to chatbots, co-pilots, agents. And so we found that having a platform like Log10 is essential for enterprises and developers that are trying to build useful systems using this tremendous power that LLMs have unlocked.
Awesome. Normally, I don't get into guest background, but I did mention you have a super unique background. You have a PhD. I just wanted maybe the audience to kind of hear. So as we talk about your background, the perspective on accuracy, we can maybe include that.
It's funny about back now, it's like 22, 23 years ago when I was entering college, I really wanted to study AI, but AI was going through what's now referred to as like the second or third AI winter. All the professors told me to go look at other areas for inspiration, and I ended up getting pretty deep into neuroscience, did a lot of research, got a PhD in computational neuroscience, working on brain-machine interfaces. And as part of that, we were using a lot of cutting-edge machine learning techniques to make sense of large data sets that we were recording from the brain. And this was in the context of brain-machine interfaces, where you're trying to control a prosthetic device by decoding the activity from many hundreds of neurons in the brain at a very high frequency. So in that sense, I'd kept up with trying to understand how the brain works and try to use some of those insights to build more intelligent systems, as well as keeping up with the latest ML to understand how the brain computes those kind of quantities and those processes. And so fast forward to about 2012, 2013, when AlexNet came out and when deep learning was really taking off, kind of caught that trend early and made the transition to industry and worked at Qualcomm Research on a neuromorphic chip project. And soon after that, co-founded a company called Nirvana Systems, which was one of the early AI hardware startups that was acquired by Intel, and went on to found another AI agents company. And so with Log10, basically been bringing together some of that experience with computational neuroscience and some of the tools that I'm familiar with that we use to try to understand how the brain works, because the brain in many ways is also a black box, and you kind of see the inputs and outputs, but it's hard to make sense of how the brain is computing all these interesting processes around memory and motor control and cognition. And in many ways, LLMs have very similar properties. They're hierarchical. They compute these abstractions in a kind of hierarchical, compositional way, but we're only beginning to scratch the surface of how they're actually doing that. So that's really the connection we're bringing to bear in some of the research we're doing at Log10 as well.
Absolutely. Very interesting. We're going to be talking about hallucinations within this episode. Obviously, everyone has, heard some kind of story, seen something posted about hallucinations, LLMs are still early days, and sometimes you look and go, well, we're still not at a mature level. I mean, we're still figuring things out. We're still learning, obviously, and it's not at a scale that I think that we're doing mission critical stuff that, if somebody's email is written a little poorly, I'm just joking. So that there are mission critical stuff happening out there. But when we talk about hallucinations, and we're talking about early days of AI. And some people would say, well, we've been doing this for 10, 20, 30 years. I get that. Mainstream is just recognizing in the last 24 months that AI is a thing that they may even been using on their phones, on the Siris, on the Alexas. But when you think about a hallucination, how deep of a problem is that within the context of where we're at within that maturity scale?
I mean, I think there's sort of this 3-tier division of AI use cases that I find is helpful to keep as a mental model. And at the simplest level are fairly standard natural language processing tasks, things like categorization, summarization, translation, extracting structured content from documents. And there's a long history of people trying to solve that in NLP. But I think what happened with ChatGPT, kind of that moment back in November or December of 2022, was that people found that you could unlock this capability just using natural language, just by prompting in English or whatever language. And you didn't need to be a programmer or a machine learning expert in order to build and deploy these systems. So I think it just became a lot more accessible. It democratized that capability. And at the same time, it did that at a pretty high level of accuracy, like close to human level accuracy for those kinds of tasks. So I think the job of a system like ours in terms of detecting and reducing or eliminating hallucinations is basically verifying that output and making sure that it's correct. But the capabilities of these systems are very strong, and they're going to keep getting better and better. At the next level, you have people who are sort of pushing on the direction of trying to make these systems more agentic and kind of more, human-like, in the sense that it's like some part of a job that somebody's doing today that they're trying to automate with these LLM or AI systems. That's, I think, where the cutting edge of the current technology is, in terms of you do notice a lot more errors. And, famously, there was the Air Canada chatbot that hallucinated a refund policy that a judge, forced them to honor. There was the Chevy truck dealership chatbot that was compelled to sell a truck for $1 through some prompt injection. We've experienced that through chatbots where we're in a hurry and trying to tackle some issue in production, and the chatbot basically is like, hey, do you want to play a game or something? So it totally misses the mark on the emotional state of the user. And then also with like semantic search engines, we see a lot of common sense errors and mistakes in the kinds of answers they give. So I think I sort of view that as the frontier of where the technology is today. People are trying to apply it in fairly narrow domains. Like each of those examples was fairly narrow, but still, it's not 100%. It makes errors. And that's sort of within the reach of a combined system where, you have a base model combined with a strong evaluation or feedback system like ours can get you an overall system that can achieve acceptable levels of accuracy. And we've seen examples of that with, for example, Klarna Publishing, that they were able to automate 2/3 of their customer support and get to like a $40 million improvement in profit based on that. And then sort of the final level is sort of the kind of the AGI, scenario where people are sort of looking for like a singular system that can handle multiple of these use cases. And that's still further out in the future, but an exciting kind of future to kind of march towards.
Awesome. Let me ask you this question, because you kind of went through some of the various states of what we're seeing in terms of projects. We're talking about hallucinations. Do you anticipate, or do you think narrow AI, does narrow AI address, I guess, how hallucinations might occur, or potential, easier path to optimizing? Or is it going to be a similar problem if it's ChatGPT, that's obviously a very broad AI, Gen AI platform, versus something that's very use case specific?
Yeah, no, I think the problem is more tractable the narrower you get. And that's exactly the spectrum along which progress is happening, even with those 3 stages I was referring to. Stage one was super narrow, very, very task specific, very domain specific. With stage two, we're trying to get to more flexible, but still within a domain. And I think stage three would be multi-domain. So that's sort of my mental model for breaking down this narrow to general access as it comes to looking at things like hallucinations.
I guess when you're looking at improving accuracy, and your product's really interesting, to be honest, because I think, and I was actually on the website a little bit earlier, and kind of looking at a use case of understanding where and how hallucinations might occur, being able to detect it. I had a guest that was on before, I think it was maybe last week, and we were talking about this and said, Gen AIs have a great way of making everything sound elegant. It sounds great. Unless you are looking for something or you're observing it, you might not notice what's happening until it's too late. I guess when it comes to trying to improve accuracy, and obviously it's a little bit black box as well for most people who are using it, right? You're a practitioner, you understand what's happening underneath the hood. But as someone on the outside who's using these black box systems, how do you know if you're starting to detect hallucination before it gets extreme, right? I mean, it could be mild, it could be extreme. How do you start detecting or noticing those things?
So there is some really interesting work happening on interpreting what's happening with the neurons inside these really deep neural networks, such as the kind that power large language models. Some of it was recently published by Anthropic, where they find that there are these individual neurons that correspond to features that the networks have learned. And that's very similar to the neuroscience literature, where a lot of it is you find neurons that correspond to specific patterns or movements that the organism is trying to achieve. And so one really interesting example from the Anthropic paper was they found this Golden Gate Bridge neuron in one of the middle layers of the network. And if they turned on its activation, the entire network started believing that it was the Golden Gate Bridge and sort of generating text as if it were the Golden Gate Bridge. I think in a hallucination context, it's basically one aspect of it is as we get this visibility into what features each of the neurons are representing, we can get more control over the outputs of the base models themselves. And then similarly, with Log10, what we're doing is building evaluation models that can probe the output of the base model. And inside of the evaluation models, we can get a similar kind of understanding of different axes of the kinds of things we're trying to evaluate, including hallucination.
When you're looking at, and I guess, when you're looking at the notion of it being a black box and solutions are being built on top of LLMs, obviously you do have APIs, you have ability to custom. There's a lot of things you can do, but there is, I guess, a component of this where if you are integrating with a larger Gen AI solution, you have a bit of your IP that sits on top and a bit of your IP is not in your own. How do you balance that? Because obviously in one case, typically when you build a solution in-house, you do it because you're trying to, you have IP that you think is worth building, or you go buy off the shelf. In this case, we're going to start seeing a partner, and it's not like the cloud, because the cloud is just providing scaffolding. Like you can do whatever you want. But I guess, how do you kind of look at that when it comes to how this IP gets split between the user and the Gen AI platforms?
Yeah, definitely. I think that's actually something we think a lot about. And the evaluation models, for example, that we built, we also build them using open source models. So it's something that the user of the Gen AI platform could own, could self-host, and that's sort of a way for them to have independent control and validation over what the base model is generating. Because that's one of the reasons to separate out the monitoring or supervision of the base model from the base model itself, which some folks are trying to use the base model to evaluate its own output, and that has a whole bunch of issues with that. But yeah, I think definitely in general, there's a lot of progress happening in open source with Llama 3, and the Databricks model, we are seeing that gap between proprietary models and open source models closing, which is really exciting for people who are trying to build systems that they want to own and self-host.
You have obviously a very different background within the space. It's perfect timing for what the industry has become. I mean, you've definitely, you're at the forward edge of LLMs, Gen AI. When you look at hallucinations, and I think we were talking about how you had the primates example. We talked about kids are a little bit of a AI project because as we teach our kids, good or bad, they're learning everything. When you are looking at LLMs and you're looking at this maybe through a slightly different lens, how do you kind of draw some of your previous experience of those maybe the primates example or whatnot?
Yeah, and I have two kids as well, so definitely very familiar with the challenges, let's say, of getting the outcomes you want and trying different ways, whether it's through reinforcement learning or positive, negative kind of feedback, or through more supervised learning, sort of demonstrating what is the right kind of way to do something. Yeah, I think that's definitely something that I think a lot about. So even, for example, with this Anthropic work where they were showing these neurons corresponding to features in these deep models, that's still a bit of a static representation. And I think some of the more interesting questions are, how does that get computed when you're trying to reason over whatever problem you're trying to solve? Because that's really where hallucinations happen, is sort of not just at the representation or feature level, but more at sort of this reasoning level. So it's sort of like you have your representation of objects, but now you're trying to answer a question of like some computation over those objects. And that's where typically something goes wrong. And that's what leads to the hallucination. So I think that's still fairly open question, both for brains as well as for artificial systems, and then as well as for kids and how to best educate them, train them in this new world.
Yeah, it's funny. As when my child was born, she's 11 now. I would joke with people like, I don't need to wait for AI. I have AI right in front of me, and amazingly, she seems to take the good and the bad, and she amplifies the bad, which is kind of scary because it doesn't take much. Like you do everything good, and then this little piece, and you're like, why'd you pick that one piece up? I guess an interesting question when you're talking about accuracy. And I guess it maybe sits across maybe data, whether we're talking about volume of data, proprietary data, general public data. Most people are familiar with ChatGPT as a Gen AI tool. When you look at data, and you're going to start seeing companies who are going to implement localized solutions on their own data, obviously that's not as big of a data pool as what ChatGPT has been trained on. Are we going to see different expectations in terms of accuracy and hallucinations as we kind of start shifting whose data is being trained on?
Yeah, I mean, I think what enterprises are doing, it depends a little bit on how much data they have. There are enterprises out there that do have, like terabytes worth of data, which could be used for training base models, but probably just much fewer of those than what you described, where they might have less data, in which case they could explore things like fine-tuning on top of some of the base models. And again, it could be an open source model, or there's proprietary fine-tuning API endpoints as well. So there is that option. And I think, there are results showing that, for example, sometimes when you fine-tune, you lose some of those general reasoning capabilities, but you improve the accuracy on the specific task you care about. So those are some of the trade-offs I think people have to think about. On the other axis, you have these very long context lengths that are being unlocked through, initially it was through Claude, getting up to the 200K context length, and now more recently through Gemini, getting into the millions of context length windows. And so that's another way to kind of keep the general reasoning ability, but stuff in more domain specific or more proprietary, more basically information that may not be in the base model, and still be able to reason over that and answer questions. In my mind, the jury's still out. I don't think there's like a definite answer for which of those strategies is the best one. It does tend to be a bit task specific and domain specific, and so requires a bit of experimentation to figure out which is the best one. And that's one of the ways in which our evaluation and feedback platform can help sort of set up those ground truth data sets on which you can measure the accuracy under these different scenarios and then figure out what's the best one to deploy in production.
As companies are starting to implement pilots, I've asked this question maybe before about ROI, and I don't think it's really an ROI question. Maybe my question is about companies are deploying pilots. They're evaluating these solutions. It's going to be dependent on accuracy. If it's slightly off, and they might go, well, it's not working because obviously maybe they didn't properly do something, right? Whatever the technical something might be here. Do you see, or how do you see these pilots working out when it comes to, hey, we should invest more? Now, a lot of people are going to go, well, we know we need to invest more. Okay, well, that's good. I know I probably need to eat less ice cream. Doesn't mean I'm stopping, right? So, but when it comes to accuracy and wanting to make sure companies are investing and understanding the pilots and understanding their initiatives, what's that correlation look like?
Yeah, I see a really strong correlation. I think the ones that have been able to cross this barrier from having a demo that they're really excited about or having a pilot that they're really excited about and then really deploying it at scale and getting that value out of the system. Accuracy has really been the biggest differentiator, and the level of importance and investment that teams are putting into that is really the biggest differentiator. So we definitely encourage folks to explore solutions in this area. Of course, I would encourage them to use ours, but they could look in the market and sort of look at the other options that might be out there. But I definitely want to see AI not hit a wall or get into another winter, which has happened in previous hype cycles. And so personally, that's what sort of keeps me going, is making sure that we really get to successful deployments and really make an impact in the world with AI this time around.
I guess maybe an ROI question. When you see people, obviously they're using your product, they want to see accuracy, they want to see if they're getting a certain value and expectation back based on pure data. Is ROI going to become, I think the answer is yes, but ROI is going to become easier as we get more results. But right now, it seems like it's a lot of art, not science. Is that a fair statement?
Yeah, I think that's fair in the sense that it's a bit of heuristics and latest research that powers those accuracy improvements. Obviously, we're trying to productize that knowledge on an ongoing basis and absorbing all the latest research as quickly as possible. So it does become more of a science than an art, and doesn't require as much investment to get to those better accuracy outcomes as it does today.
Awesome, man. I really appreciate all the insights. I really like the product as well. If somebody wants to learn more about the product, get in touch with you because you mentioned something that they're curious about, what are good ways of connecting with you and the company?
Definitely encourage folks to check out our website, log10.io. We have a free self-serve sign up so people can go and play with it and get an impression of what it's about. And for me personally, people can hit me up on LinkedIn or on X. My handle there is Coffee Phoenix.
All right. I love it. I will make sure we get some of those links in there. Arjun, thanks for being on. Thanks for sharing. I really do appreciate it.
Appreciate it. Thanks a lot, Amir.
Absolutely. That's it for the episode. We'll be back again, different guest, different topic. Until then, two things. One, I think Arjun has a phenomenal background when it comes to LLMs, understanding accuracy, training. He's got a super background that's deep, multifaceted, he's seen a lot of this. So share this with somebody else who might be interested in hearing a little bit more about hallucinations, accuracy. Check out Log 10, really, really interesting product for this use case. Share, subscribe, let me know how the podcast is going for you. Until next time, thank you and goodbye.